Welcome to Neon Math. Let's solve equations using addition or subtraction. Before we begin, let's just discuss, you've heard it before, pre-algebra, algebra, etc. We are looking for the unknown. We're trying to figure out what is x, what is q, what is y, whatever letter we decide to use. Each problem, we could have a different letter. It's a different puzzle. But our job is to figure out what does it represent in this particular problem. I'd like to talk about opposite and inverse operations real quick. Today we're dealing with addition and subtraction. Addition and subtraction are like partners. In arithmetic, addition is wonderful for undoing subtraction, and subtraction is the opposite of addition. We're not doing this today, but opposite of multiplication is division. Someday we'll talk about square roots and squares. Okay, let's do a problem. My first problem, I have this little number sentence. I can almost think, when we're dealing with addition and subtraction, almost think of these as words in a sentence. And they're very simple to move around to the other side of the problem. When we're dealing with multiplication and division, a little tougher to move things around. We got to think it through. But in this case, I want x by itself. At the end of this problem, I want to know what x equals. So I got to clear this out of here. It happens to be a positive 7, so I'm going to do the opposite of addition, which is subtraction, and I'm going to move that to the other side of the equal sign by subtracting it. 7 minus 7 is 0. And this gives me x equals. Now I just got to think, what's 14 minus 7? We know it's 7. Feel free to use a calculator if you're allowed to. Let's plug it back in. Is 7 plus 7 14? Yes. Next problem. Ooh, got a little negative number in here. Let's see what we'll do. We have a q here, and we want this q by itself. We want q by itself. It happens to be positive q, which is great. It's ready to go because at the end of the problem, we want to know what positive x is or positive q is. Looking ahead, uh-oh, I have a negative y. That's going to be something I'm going to have to deal with. But in this case, we just want q by itself. It's great. But when we're figuring out opposite operations, this is what I'm looking at. I'm looking at what's in front of my number. And in this case, it's a negative. Opposite of a negative 7 is a positive 7. So I'm going to add this 7 to here so it cancels. Opposite operation. And I'm going to also add it to the other side of the equal sign. So I'm basically adding a 7 to each side of the equal sign. 7 and q don't add together, but this 7 and minus 7, yeah, they sure do. They cancel out, giving me 0. So I have q equals 15 plus 7 is 22. Sounds like a good answer. Let's plug this in. Is negative 7 plus 22 15? Or would 22 minus 7 give me 15? Yeah. All right. This one's a little weird over here. And we're not doing multiplication or division in here, so we have to do, I guess you could call it a little trick. A little finesse in this equation. I could just go ahead and subtract this 6 to the other side, get my numbers together. They're sitting there ready to go. And 11 minus 6 will be 5. But I'm not done yet because it says negative y equals 5. And then I can add this y over to the other side. Those would cancel, give me 0 equals 5 plus y. I want y by itself, so I'm going to get rid of this 5 and subtract it over to the other side. And that's going to give me negative 5 equals y, or as I like to put it, y equals negative 5. See, I just flipped those backwards. I could have stopped right here and just said, hey, I could flip this to positive and that to negative, but it wouldn't feel right if I don't know why I'm allowed to do that. So until we are working with multiplication and division, we're not doing that. Let's check out this negative 5. Is a negative negative 5, which makes positive 5, plus 6, 11? Yeah, sure is. Will I ever use this in the real world? Well, you kind of already do. Lots. Okay, let me try my little AI app. Okay, we're going to the, here we go. Guess we're going to the nursery. Going to the nursery to buy plants, soil, etc. We go there, we count up how much we have in our cart, and we have $53.75, which is a problem because we only brought $46.25. The question is, how much more money do we need to fulfill our list? Or how much do we need to take away if we need to subtract it? But we're going to say, hey, let's go out to the car and see if we can scrounge up some extra change to come up with the difference. How short are we? Okay, this is a pretty straightforward problem. What we have in our pockets plus what we need equals, plus what we need to make up the difference equals our total. I'm going to subtract this 46.25 to both sides. That cancels, and I'm left with x equals. I'm going to use a calculator for this, but if you don't know how to subtract decimals, go look it up after this and learn how to subtract decimals. Quick tip, you gotta line them up when you subtract them. Okay, 53.75. I'm in the store. I'm not sitting there with paper and pencil messing around. Minus 46.25 equals, $7.50. X equals $7.50. We need to run out to the car and see if we can scrounge up $7.50, like bridge toll money or whatever. Okay. X equals $7.50. Let's do a couple more problems. Guess we should probably do a fraction problem. 2/3 plus x equals 4/6. This happens to be a positive 2/3. There's no sign, it's positive. I'm going to go ahead and subtract this 2/3 to both sides of the equation. I'm going to write it next to it because I know that's how I like to do fractions. Some people like to write them on top of each other. You do what you want. Doesn't make a difference. And x equals. Now, I can't subtract these until I have common denominators. So I have a 6 here. If I can turn this 3 into a 6, I'm in business. How do I turn a 3 into a 6? Well, I multiply it by 2. But I can't do that unless I do it to the top. So I supersize this fraction, turning it into 4/6. That's interesting. Now they're both 4/6. When you subtract fractions, I like to grab the denominator. Okay, you don't subtract the denominators. You grab your denominator and you subtract the numerators. In this case, it's 4 minus 4 equals 0, and 0 divided by 6 is 0. X equals 0. That's interesting. Okay. I'm feeling weird about this. I'm going to go ahead and check it out. Plug in 0. Is 2/3 plus 0 equal to 4/6? Well, it doesn't feel like it, but when you realize that 4/6, if I were to go over here and reduce 4/6, it is 2/3. Okay, it was just in disguise. Whew, fractions can be tricky. Let's do one more. This one's going to make us mess with negatives. Got this positive 3 sitting here. I'm going to subtract it to both sides. It's gone. And I'm left with y equals. Now, what is negative 16 minus 3? Or what is a negative 16 plus a negative 3? Well, we're combining things together. We're adding them, right? A negative 16 and a negative 3. If I owed $16, owed $3 more, I would owe $19. When they have the same sign, you just add the two numerals. So 16 plus 3 is 19, and you keep the sign when they're the same. So negative 19. Let's see if that makes sense. Negative 19 plus 3. So if I owed $19, paid $3 back, I'd have $16 owing. Yeah, makes sense. All right, it's your turn now. Time for you to take this home. Go ahead and pause the video and try this self-assessment. Your goal is to get Well, of course, you want all of them right, but if you can get 3 out of 4 right, you're on the right track. All right, welcome back. Let's do this. Opposite of minus 11 is plus 11. And if I do it to one side of the equation, I'm going to go do it to the other side. 11 plus 2 is 13. 13 minus 11 is 2. That one works. Ding. Ah, we got some decimals. I'm going to go ahead and subtract 11.5 to both sides. In my mind, I think of it as like 11.50, like money. If I had $13 and something cost $11.50, how much would I have left? Well, it'd be $1.50. Feel free to use your calculator if you're allowed to. 11.50. 11.50. To get up to 13, you can kind of count backwards if you were counting money like that. So 11.15 up to 12 would be 50 cents, and 12 to 13 is one more dollar, so $1.50. Let's see if our answer works. $1.50, plug it in here, or 1.5 plus 11.5. I could think of adding the 1 plus the 11, giving me 12, and then 0.5 plus 0.5 is 1, so 12 plus 1 makes 13. Yeah. If I talk too fast, hit the gear down here at the bottom of your screen and go to playback speed. And if you want me faster, speed it up. If you want it slower, slow it down. All right. Opposite of minus 5 is plus 5. Notice I'm always looking at the sign that's in front of my number. I don't care what's in front of my x until it's a problem, which is the next problem it will be. Okay. Negative 5 plus 5 is 0. They cancel each other out. When anything meets its exact opposite, they turn to 0 in addition and subtraction. Over here, see, that's a problem. I can get this y by itself, but it'll still have this negative on the front, so I'm going to have to deal with that. Okay, I think I'm going to do it a kind of a weird way this time. I'm going to subtract the 6 over here. $12 minus 6 is 6. I don't often pile everything to one side of the problem until I'm doing trinomials later on. What about this y? Let's move it to the other side. Why am I doing that? Because I want the y to be positive. And so we're left with 6 equals y. I'm not going to leave it like that because I like it to look like y equals 6. So I just flipped it backwards, same thing. Let's see if this works. A negative 6 plus 12, or 12 minus 6, would give me 6. Yeah, I did great. All right. I hope you got 4 out of 4 right or 3 out of 4 right. I hope you learned something today. It's been great. Thank you.